Today we're going to talk about the greenhouse effect and as well as global climate change along with that. So let's start by talking about what is the greenhouse effect. The greenhouse effect is when gases in the atmosphere traps radiation that is being reflected back from the surface, and this conserves its heat or traps that heat in. So the sun shines down, and these gases in the atmosphere then trap all of that heat against the Earth's surface. Many human activities are actually increasing the level of greenhouse gases that are being put into the atmosphere and producing changes in the climate worldwide. This increase is causing global temperatures to rise, and this is what we call global climate change. So, certain gases are considered greenhouse gases, like CO2, and this type of gas is what helps to really trap in that radiation or that heat better than other gases may, or the normal composition of the atmosphere. So, what are the greenhouse gases? Well, as you can see from this pie chart, CO2 or carbon dioxide is the biggest contributor at 82%. And then at 10%, we have methane, 5% nitrous oxide, and then fluorinated gases contributing just about 3% more. So this is just a diagram of the greenhouse effect. And so what you see is you have this solar radiation that's being reflected by the Earth and the atmosphere. Some of it is reflected and goes back out. Most of the radiation is actually absorbed by the Earth's surface, and it warms it up. Some of the infrared radiation passes through the atmosphere. Some is absorbed and re-emitted in all directions by greenhouse gas molecules. And the effect of this is to warm the Earth's surface and lower the atmosphere. So the infrared radiation is emitted by the actual Earth's surface then. And all of these things together cause this greenhouse effect. So much like a greenhouse would work in real life with the glass is kind of like that. Is the same as the atmosphere is for the Earth. So you can think of the atmosphere like this glass house on a greenhouse. So as the sun comes down, it radiates this heat into, and then it's trapped by this glass, so that it cannot come back out as easily as it was able to come in. So there is a natural greenhouse effect where some of the radiation is trapped in and a lot of heat actually escapes into space. But because of human impacts, there's now this enhanced greenhouse effect. So you have this solar radiation, and now there's more of these greenhouse gases that we talked about, the methane, the nitrous oxide, the carbon dioxide. And because of these, instead of having this less re-emitted heat, you have more of that, which comes back down to the Earth, and you have less heat that's escaping into space, as opposed to naturally when more of it would escape. And you can see that just in the actual thickness of the arrows that are drawn here to kind of indicate more and less heat. So, now that we've talked about the greenhouse effect, let's talk about global climate change. So what is global climate change? It's otherwise known as, but I do not encourage, the use of the words global warming. It's occurring when humans are adding too much of these heat-trapping gases, these greenhouse gases, into the atmosphere, causing too much heat to be trapped. And this increases the average air and ocean temperature. So both the air and the ocean are increasing in temperature. The effects of global climate change or global warming include melting glaciers, rising sea levels, drought, desertification, changes to the biosphere, and regional changes in temperature. So this is the observed U.S. temperature change, and you'll notice that any change greater than 1.5 degrees Celsius or Fahrenheit average is marked in this dark red. So one thing you'll notice is that most areas in the United States are areas that are heating up with this red. Now, one thing I want you to notice is down in the south, there are a few areas that are this blue coloration, and these are areas that are actually, on average, cooling a little bit. So, one thing to notice is that this is talking about the average temperature change for an entire area. And so, one of the reasons we call it global climate change instead of global warming is that some areas are getting warmer while others are getting cooler. This is a map that was made by the US Navy to kind of show you what will happen if we continue to go the way we are going and the temperature continues to rise in the sea and the air, and these glaciers melt up at the poles in the glaciers that are anywhere near the northern and southern parts of the Earth. You'll notice that these new water lines that are drawn, this is where the new coastlines would fall. And you'll notice that the entire state of Louisiana would be gone. So this graph is one that shows you that global temperature range from 1880 to 2000. So you'll notice that we had this temperature average somewhere below 57.5 degrees. And as the CO2 concentration within the atmosphere increased, the average global temperature also began to increase, really starting to take a turn somewhere around 1970 and 1980. This again shows you the global average temperature and its changes. Now, one thing to notice is that this does go from 56.3 to 97.92, and you might think that's not a big enough temperature change, but in reality, even the slightest temperature change of just a few degrees, which can happen just over a couple decades, this can really, really influence the melting of these ice caps at the poles. So, what is the impacts of global warming? So this is what I was talking about. As the temperature increases, just 5 degrees total, you go from, in these areas, some risks or few risks to very, very high risk for anything. So ecosystems, lots of them with a 5-degree increase would have really high risks. The extreme weather would increase in frequency with just a 3 to 4 to 5 degree increase. And you'll notice that somewhere around 2.5 degrees, the distribution in some of the regions, it's really negative. The economy and ecology, also around 2.5. And the irreversible and abrupt changes around 5 degrees is when we're at a really high risk for a higher frequency of those. So the potential impacts of global climate change on human health. So this is a little bit blurry, so bear with me, but the global climate change affects the temperature, the sea level, and the precipitation. So with storms and flooding, you have a lot of morbidity, mortality, or displacement of people. With the heat, once again, this mortality starts to increase. It says vector biology, and what that's talking about is infectious diseases. So these are diseases that can be spread from person to person, and as you see these people being displaced or moved towards other areas, or the temperature increase, you do have an increase in these infectious diseases, or the occurrence of them. Air pollutants, which can, as those increase, it causes respiratory diseases. The food supply, which influences malnutrition, and civil conflict. So people start to fight and argue over the resources as they become more and more limited. Let's move on to a little bit of benchmark review before